Hello everyone. Assalamu alaikum. Welcome to our group project Nova Byte. Before starting our MATLAB based material project, we first try to understand some basic chemical related problems. Because without understanding the chemical concepts behind the data, it is difficult to build an accurate and meaningful application. Here we are given pressure tables and temperature tables for saturated and superheated steam. However, we can observe that these tables provide values of properties like specific volume, internal energy, and enthalpy for certain discrete values of pressure and temperature. Similarly, in the temperature table, the data is available only for specific temperature points, not for every possible values. Similarly, now suppose we need to find properties at condition of 8.1 bar or 86.5 bar. In these cases, we cannot find the exact value from the table. The same issues appear in the superheated steam table. Let's see. Here we can see the superheated steam table. For example, values may be given at 145.8 degrees Celsius and 0.1 bar. We need the results at the temperature like 22.2 degrees Celsius or 230 degrees Celsius. For those exact values are not available in the table. As a result, we are forced to use interpolation to estimate these missing values. But manual interpolation is time-consuming, complex, and prone to error. To overcome this difficulty, we developed our MATLAB application. Now we will see how our MATLAB application works. First, in our main interface, we can see two options: saturated steam table and superheated steam table. This means our app allows users to work with both types of data. Let's start with saturated steam table. After entering this section, we can see the different types of inputs such as temperature, pressure, enthalpy vapor, enthalpy liquid. For example, if we select pressure as input and enter a value like 30 bar, let me clear it, like 30 bar, and then press calculate, we can see that the app shows only out of limit indication highlighted in red. This happens because the value is outside the value range of the dataset. We can see the range from 00 to 22.06. However, if we enter and value data like 10, let's say, we can see if we choose however, if we enter the value data 10 bar and press calculate, the app successfully displays the corresponding results. This includes temperature, enthalpy of liquid, enthalpy of vapor, and entropy of liquid, entropy of vapor. Similarly, if we choose temperature as input, we can see the range 0.001 to 373.95 degrees Celsius. If we enter outside this range, the app again shows an out of limit warning. This ensures that users only work within the data and the boundaries. We can also calculate, for example, enthalpy liquid, we can see 1410 calculate. We can see temperature, pressure, and enthalpy for liquid, enthalpy of vapor, entropy of liquid, and entropy of vapor. Finally, by clicking the back button, we can return our interface. Now let's move to the superheated steam table section. After entering this part, we can see the temperature and pressure given in Celsius and megapascal. For example, if we enter 10 megapascal and 100 degrees Celsius, the app provides thermodynamic properties like entropy, enthalpy, specific volume, and internal energy. In addition, the app also shows the phase to the substance, whether it's liquid, vapor, or supercritical. Let's move to the higher value like 10 degrees Celsius and 800 degrees Celsius, 10 megapascal. Let's calculate. Now we can follow the properties values change accordingly. At the same time, the phase also changes, and in this case, it indicates the vapor phase. You can immediately observe that all the property values change accordingly. At the same time, the phase also changes. In this case, it indicates the vapor phase. To make it more user-friendly, we have used color indicators. Yellow represents vapor, blue represents liquid, and red represents the supercritical region. Another important feature of our app, it can also handle fractional values as well. Let's see, like 100.6 and 180.7. Let's calculate. Now we can see also it also observes enthalpy, entropy, and specific volume and internal energy correctly, and also the phase reached to the supercritical. Therefore, using the superheated steam module, we can easily determine properties like enthalpy, entropy, and specific volume, given pressure and temperature. Finally, by clicking back button, we can return to the main user interface.
Let's look under the hood. While the UI is sleek, the real engineering of NovaByte happens here in the code view. The entire backend is built on a robust object-oriented MATLAB framework. When the user triggers calculation, the app dynamically reads our Excel database. For the saturated module, we built a highly efficient one-day engine using MATLAB's interp1 function. We specifically pass the raw data tables through a unique array filter to eliminate duplicates, guaranteeing the mathematically stable interpolation across every property. Now, for the superheated steam module, the math goes three-dimensional. We implemented the scattered interpolant to construct complete computational surfaces. By feeding it two independent state variables, the algorithm simultaneously reverse interpolates all the other thermodynamic properties and even detects specific phase in milliseconds. Finally, we bulletproof the engine with the try and catch function. Now, if a user inputs a mathematically impossible state, or our code intercepts the crash, flashes a custom UI alert, and turns the input box red. It is a mathematically rigorous, fully stabilized engineering tool.
So this includes a brief overview of our project. We believe our application makes the process more efficient and user-friendly. We would highly appreciate your valuable feedback and suggestions. Thank you for your attention.